Hello dear learners, welcome to our 7th lesson. Under this we are going to look at the type of changes on substance when they are subjected to heat. We'll start by temporary and permanent changes. Substances undergo various changes when subjected to different conditions of temperature. This section clarifies or classifies and defines changes that take place in substances. When zinc oxide, this is a formula ZnO, is heated, its color changes from white to yellow. On cooling, the yellow solid turns white. This change can be represented as zinc oxide. You heat, you get zinc oxide, which is yellow, and when you cool, you get back to white solid. Wax melt on heating. When cooled, liquid wax changes back to solid. Solid wax, you heat, you get liquid wax. When you cool, you get solid wax. When iodine is heated, the shiny black solid turns to purple vapor. When cooled, the purple vapor changes back to the shiny black solid. So iodine, when you heat, it sublimes to iodine vapor, which is purple in color. And when you cool, it deposits, or there is the process of deposition back to solid shiny black, that is iodine. This process is known as sublimation, where the solid changes directly to vapor or gaseous state without passing the liquid state. So when zinc oxide, wax and iodine does not result in the formation of new substances. On cooling, you get the original substance. Since on cooling, you get the original substance. So a change which can easily be reversed and in which no new substance is formed is called temporary physical change. The characteristics of temporary physical change are 4. 1. They are easily reversible. Then 2. We have no new substance is formed. The mass of substance does not change. And finally, they are not accompanied by net heat change. So the example are zinc oxide, wax and iodine. They do not form new substance. They are easily reversible, no mass change, and they are not accompanied by heat change, or no heat is generated. So let's look at temporary chemical change. Example 1, copper 2 sulfate, which is blue in color with water of crystallization, is said to be hydrated. When heated, it decomposes to produce white copper 2 sulfate powder. The formula is start with Cu for copper, S for sulfur, and O for oxygen, but this one is termed as sulfate, and water, which is H2O. The white copper 2 sulfate powder does not contain water of crystallization, and it is said to be anhydrous without water of crystallization. So presented with this word equation, hydrated copper 2 sulfate, this is with water of crystallization. When you heat, it loses the water of crystallization to form white copper 2 sulfate. So this is a setup where you heat, the water of crystallization escapes through the delivery tube, cooled down to water, which is a colorless liquid, and that is why you have ice cold water to cool or to solidify or make the vapor turns to liquid by removing the energy, kinetic energy. When the white anhydrous copper 2 sulfate does not regain its blue color upon cooling. So this one, upon cooling, does not regain the blue color. Example 2, the same case happened to pink hydrated cobalt 2 chloride, which turns blue on heating. So hydrated cobalt 2 chloride has water of crystallization. When it is heated, what happens? The water of crystallization disappears, and you're left with blue anhydrous cobalt 2 chloride. So the decomposition of substance when they are heated is referred as thermal decomposition. The word thermal comes from heat or temperature. So heat is evolved when erythritol water is added to anhydrous copper 2 sulfate or to the blue anhydrous cobalt 2 chloride. So there is that generation of heat. They become hydrated again when you add water and they regain their original color. They have 4 characteristics. That is, temporary chemical change have the following characteristics. 1. New substances are formed, like in this case, this is a new substance called cobalt chloride, which does not have water of crystallization. Then energy is involved when you add water to regain their original color or the substance. In addition, there is a change in mass. When this water of crystallization disappears, then the weight of cobalt 2 chloride is less than the original. Then 3, the change can be reversed. So this change can be reversed. You need to add a little water to the anhydrous product to get the original substance. Note, the temporary change may be physical or chemical. In temporary physical change, no new substance is formed. In temporary chemical change, new substances are formed. However, the two changes are reversible, hence temporary reversible. We continue to permanent chemical change. Example 1, copper 2 nitrate is heated. When it is heated, it decomposes to form black solid and a mixture of gases. So subjected to thermal decomposition, the black solid of copper 2 oxide are formed. The mixture of gases contain red-brown gas and other gases that rewrite a glowing sprint. The lead-brown gas is nitrogen 4 oxide, while the gas that rewrites a glowing sprint is oxygen. Copper 2 nitrate, the formula is given that way. This is copper and this is nitrate. So Cu, note this one is small u. Then we have NO3 into bracket 2. So this one is blue in color. When subjected to heat, then it decomposes to form copper 2 oxide. The symbols, the equation. Then nitrogen 4 oxide, NO2, which is a red-brown gas. Then we have oxygen gas, which is colorless but rewrites a glowing sprint. That is how you test the presence of oxygen, by writing a glowing sprint. The mass of copper 2 oxide is found to be less than that of copper 2 nitrate, since the gases produced escaped to the atmosphere. Example 2, potassium permanganate 7 decomposes to form black green solid and colorless gas, which rewrite a glowing sprint, meaning this is oxygen. So here is a word equation, potassium permanganate 7, which is purple in color, then heated to form green potassium permanganate, potassium manganate 6. The formula is given there, which is green in color. Then manganese 4 oxide, Mn, the small n, O2, black solid, and finally we have oxygen, which is colorless, that rewrites a glowing sprint. The black-green solid is a mixture of potassium, green potassium manganate 6 and black manganese 4 oxide. The black-green weighs less than the original potassium permanganate 7. In permanent chemical change, the composition of copper nitrate and potassium permanganate 7 are examples of permanent chemical changes. Permanent chemical change have the following 4 characteristics. 1, new substances are formed. Then changes is irreversible. It is difficult to get to the original substance. Then there is a mass change, and then heat is evolved or released or absorbed when you want to regain. Here is a summary of the three changes. We have temperature, we have temporary chemical, physical, and permanent chemical. Substance formed. No new substance is formed in temporary physical change. Then change is irreversible. There is no mass change, no heat energy is released or absorbed. Example, zinc oxide and wax and iodine. Temporary chemical change, new substance is formed, change is reversible. There is mass change, heat energy is released or absorbed. An example is copper 2 sulfate and cobalt 2 chloride. Permanent chemical change, new substance is formed, change is irreversible. There is a mass change, heat energy is released or absorbed. Then example, you have copper 2 nitrate and potassium permanganate 7. Here is the assignment. Make sure you answer before you proceed to the next lesson. Wish you success and thank you for your time.